first thing, yesterday we had our homework due that was looking at ethical dilemmas with statistics, and we know that with a lot of those, there's no like right or wrong answer necessarily. I think the only thing that had correct answers was the one question that you submitted about the confidentiality versus anonymity. Okay, remember, something's confidential, it's kept private. If something is anonymous, then you don't know who's responding to what. Okay, the researcher doesn't know. And obviously that would be kept private as well. So there were 4 questions that I had you submit through Canvas, and then there was also one discussion response that I wanted you to respond to. And again, they're more like jumping off points where you're trying to weigh like the pros and cons. Like ethics are not cut and dry. Okay? Sometimes you are presented with a scenario that, well, if you put yourself in the position of like this party, you can see why they would want to do it this way. But if you put yourself in the position of the participant, you can see how you'd want it to be done just the opposite way. So a lot of times it's not that simple, and I haven't read through all of those discussions yet, but I kind of browsed through a little bit on Friday and a little bit yesterday, and it seems like there were some good thought-provoking comments left by people. Did anybody want to add anything to any of that you had done? Okay. All right, so the format of our test coming up on Friday. I have 40 points, and that's comprised of 16 multiple choice questions and 2 or 3 open response based on the version that you get. By open response, this just means like a brief written part. It's not an essay or anything. It's like a sentence or 2 to answer the question. Okay? And later on in this document, you'll see that there is some practice open response questions. The suggested homework assignment, it's not anything that's graded, it's not due, it's nothing you need to submit, but the chapter 11 stuff in this book is a review assignment that focuses on multiple choice practice. Okay, so that is available to you. As I said, I wanted to take some time today to just kind of review and refresh ourselves with some of our big points. Okay, in chapter 8, we looked at sampling. So I want to spend some time talking about the sampling methods. Chapter 9, we were looking at randomized experiments versus observational studies. And then most recently, chapter 10 was ethics. So let's start a little bit by talking about population versus sample. Our goal of any analysis, any statistical analysis, is to talk about the population. I say this in the most sincere way. Like, you don't care about the sample in terms of what exactly the percentage is that go this way or that way. You care about how well that sample represents the population as a whole. So you might be asking, why not just survey the entire population and perform a census? Well, censuses are too costly, too time-consuming, usually too much effort. Remember, we did our farm sampling activity where part of that, the last thing, was for you to do a census and add up every single value in those 100 blocks. Now, on one hand, that's like the easiest census that you could ever do. But on the other hand, it took time, it was a little bit tedious, and just by going through that assignment, many of you did not have the correct answer, and I don't blame you. It's easy to slip up and type in the wrong numbers on the calculator when you're adding 100 numbers together. So a census, a lot of times, is not practical. So we put our time, our money, our effort in to getting a well-designed sample to represent that population. We have some sampling techniques here. And flip screens to take a look at this. These sampling methods, I've separated them into good methods and bad methods, right? We still refer to these types of samples because we need to be able to identify when, like from some scenario, we have a convenient sample or a voluntary response sample. And we'll talk about why those are bad. Yeah? But let's start with the good. Simple random sample. Yeah? Simple in that it's easy to think about what's being done. Okay? This could be as easy as putting everybody's name in a hat, mixing it up, and pulling out however many you need. Or everybody in the population, you give them a number, use that random number generator that we talked about to help you obtain your sample. Now, the big drawback of a simple random sample is that you need that list of everybody in the population. That's called a sampling frame. Okay? Think about it. Even if you're putting them in a hat, you have to have everybody in that hat. If you're giving everybody a number, okay, you have to have that list. And if you're talking about a very big population, that's not always practical or possible. Okay? Now, if we're talking about our school population, yeah, we might be able to get something like that. But not always as easy to go with a simple random sample. And you might be seeing simple and thinking it's easy to do. Not always. Okay? One of the activities that I used to do, well, hopefully I can get back to it in future years, but it wasn't really practical to do it this year with our format, was we go out to the parking lot and we're trying to, like, we pick some characteristic of a car. Okay, so it could be like a red car, or it could be like Honda or something like that. And you're picking a sampling method to try to estimate the percentage of, for example, red cars in the entire parking lot. And at the end of it, you do a full census to see how accurate that prediction actually is. Now, it's pretty much impossible to do a simple random sample for that because we don't have that sampling frame. Maybe, like Chief Bryson, the school police, maybe they have a list, like when you register for your parking tab thing, like you have to give your make and model of the car. Like maybe they have that, but they're not going to share that with us. And so it's not really practical to use that method there. So some of these other methods might make a little bit more sense in that kind of a scenario. The next two methods, stratified and clustered. Both of these involve grouping. Stratified, the groups are called strata. And what you do is split them into the groups that usually have some identifying characteristic to them. Okay? And once you have your groups, you're then doing a simple random sample within each group. If you're to talk about the parking lot for that, we have some pretty distinct groups there in that you have the faculty lot in the front, you have the student lot up on the hill, and maybe if you wanted to count like the short-term lot out in front here as a third group, you could. Now, you're still simple random sampling within each of those groups, and again, you don't really have a frame for those groups, so you might want to stratify a couple times over or do a multi-stage sample, okay, where you then use another method. Okay? But the big perk of stratified is that you not only have the values for the entire population, but you also have the ideas for each group, and that could be relevant. Okay? If you're talking about like a nationwide scale and you're stratifying by state, you might want to know what the opinions are in each state, and then put it together for the entire country. Or maybe the characteristic, maybe not red cars if we're talking about the parking lot, but if you're looking at maybe like a luxury car model or something like that, comparing the faculty lot to the student lot, maybe that's a comparison that you could make from a stratified sample, that if you're just throwing everybody together, you wouldn't be able to make that distinction. Okay, so one of the reasons you might go with a stratified sample is that those values within the groups have some meaning to you and your result. Cluster sampling, a lot of times the groups, the clusters, do not have a unifying label. Okay, they don't have a characteristic that helps identify that group. And remember that when we were talking about this for the first time, I mentioned the college dorms, and each dormitory has 6 levels. So your clusters were floors in the dorm, and you're taking a simple random sample of the groups. So with the parking lot, let's say we have the rows serving as our clusters. Okay, who cares if you're in row 1, row 2, row whatever? Okay? Unlike stratified, we don't care about the proportion of red cars in that row. Okay? But that could help us get an idea about the full population. So the big benefit of cluster over stratified is that you do not need a sampling frame. You don't need that list of everybody in the population. Because with this, you're taking a simple random sample of the groups. So let's say I have 20 rows of cars out there in the parking lot. Use my random number generator, row 3, row 9, row 16. Those are the rows I've selected to be in my sample. I go to those rows, count how many total cars in the rows, and count how many of them are red cars. Red divided by total, there's my proportion, my sample proportion. Okay, and I can use that as a guide for the accuracy of the entire population. Any questions on the differences between stratified and cluster? Keep in mind, guys, this is an open book, open note test. So, I'm spending a good 15 minutes going over these sampling methods. You will have questions on these sampling methods, so if you want to jot down some notes about what each one of these is or examples of them, then this is to your benefit. All right. Systematic samples. With a systematic sample, you're following a process, you're following a system for obtaining that sample. Now, you do need a sampling frame for this. Remember, this is every 5th element is in your sample. Now, students seem to love using this method for the parking lot activity because it was really easy to do. You could stand up on top of the hill, the top of the stairs there, and look down on the parking lot. 1, 2, 3, 4, 5. Is that car red or not? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's a systematic sample. It's really easy to perform if you have that population in front of you. Now, you do need to make sure that you pick a step size that gets you through the entire population. Because a lot of times, those sampling frames are alphabetized, and if you're not careful and your size is too small, you might not get out of the ABCs, and that would be biased towards the beginning of the alphabet. Now, maybe that's relevant for whatever you're sampling about, maybe it's not, but again, we're thinking about possible sources of bias, okay? So we need to make sure that anytime it's possible that could lead to a biased result, we need to try to eliminate that. So, good rule of thumb, if you have a rough idea of how many are in the population, divide that by what you want your sample size to be, Okay, total divided by sample size, and that should give you the step size that would get you through pretty much the entire population. Already talked a little bit about multi-stage, okay, just a combination of these different methods. We've seen that like on the national scale, where maybe you stratify a couple times, like stratify by state and then stratify by county, and then you have more of a manageable size. You're taking like clusters of towns in the counties, and then, yeah, maybe that's all you need to do. It's just a combination of different methods. We're starting to transition a little bit here from the good to the bad. I don't have this written here, but let me put it off to the side here, kind of in both. Random digit dialing. Okay. Random digit dialing like used to be the big thing in how big samples were taken, but we're starting to see a lot more flaws with the random digit dialing. Okay? That people just don't respond to them, and that non-response rate almost turns it into a voluntary response. Okay? If you're getting 10% of the people who you try to actually participate in this, okay, you got to think about, well, why are those 10% actually participating? It's kind of becoming one of these poor methods. So random digit dialing, like years ago, decades ago, when you're calling a landline, there's a single landline telephone number per household. There was no caller ID, so like pretty much any phone call that came was a relevant, meaningful call. We weren't flooded with spam calls like we are today. So if somebody calls, it's going to get answered, and the person who picks up is probably going to participate and go along with whatever's being asked. But now, times have changed. Okay, the proliferation of cell phones and caller ID. Okay, you can determine like what you want to do. Do you want to take this call or do you want to ignore it beforehand? So it's getting to be a less accurate method. Now, our bad methods: convenience sampling. Convenience sampling, we saw this with our farming activity. There's no way to regulate the accuracy of a convenience sample. In our farm activity, a common convenience sample is to take the plots of land that were closest to our farmhouse. But those plots had the worst yield of the entire farm. And we gave a couple reasons for that. Maybe they were used year after year, so they were nutrient deficient. It was the furthest away from the river, so maybe it wasn't properly irrigated. There's no guarantee that it's bad, but the chance is too great for it to be bad. That we are trying to eliminate all possible sources of bias. Okay, so it's best to avoid convenience sampling. I said the rule of thumb is the easier it is for you to obtain your sample, the less representative that sample is. Now, the worst type of convenience sample is a voluntary response sample. Voluntary response is when you sit back and you let the participants come to you. So, like Twitter polls, any media survey or media poll where you have to go to this website or you text this to this number, okay, to let your opinion be known, they are voluntary response and they are extremely biased. We've said this before, that those who participate are likely to have strong opinions. So you're leaving out those people in the middle, and sometimes those strong opinions are very one-sided. It's not like you're getting a polarized set. Like if you're talking about cable news channels, we know these networks have leftward leanings or rightward leanings. So if you're then surveying those viewers on a voluntary response basis, the people who want to make their opinions be known and they're pigeonholed into these political beliefs already, okay, they are the ones who are going to respond on the extreme, passionate, opinionated end. Okay. Voluntary response polls are garbage. They're worthless. Like, who are you trying to represent? Because it's not the American people. It's not all registered voters. It's not even the viewers of that network, if you're talking about the cable news. Okay? It's the opinions of people who chose to respond. And who cares about those people's opinions? Right? It's not representative of a larger population. All right, any questions on that, sampling methods? Guys at home doing good? All right. So let me go back to my other document here. Okay. We've just talked about our sampling techniques. Sources of bias. We've already mentioned a little bit of this. Poor sampling methods can certainly lead to bias. Undercoverage and non-response. Okay? Non-response we mentioned with the random digit dialing. If people just don't participate, okay? That's bias because typically there's a reason why they are not participating, and you need to kind of figure that out. Undercoverage. If you're not getting to a particular part of the population, that's unrepresentative of the population itself. We've spoken about that in respect to the polls with the 2016 election. 2020 election, we really haven't been able to reflect on that, but the polls, there's still an argument that the polls are flawed and they're not working the way they're supposed to be. I mentioned in our class right before the election that the last poll in Pennsylvania predicted that Joe Biden would win the state of Pennsylvania by about 5%. It turned out that he won by 1%. It predicted that in Florida that Joe Biden would win by 2%. He ended up losing by 3%. So some of that might be within the margin of error, but those two cases that I just mentioned are not. So, and there are a couple others that it's a little bit difficult to predict. There's some undercoverage there, and there's also these ideas that people have recognized that the polls are kind of flawed and unpredictable, and they are refusing to participate in the polls sometimes, which leads to more non-response. And if it's a particular part of the population that's refusing to participate, it's leading to more undercoverage. Okay, so those pollsters and those polling organizations have their work cut out for them to figure out how they can kind of justify their job performance and get them to be a better representation of what's actually happening at the voting booths, because they're suffering and it's just getting worse. Okay? Because people are not trusting them, it's kind of snowballing out of control and leading to more non-response and leading to more undercoverage. With respect to an experiment, the lack of blinding can also facilitate more bias. And surveying, we've talked about the wording of the question itself, can lead to a biased response. Okay? In addition to many other things. Our goal is to try to recognize possible sources of bias and do what we can to help reduce them. Okay? Things like blinding and placebos can help reduce bias. Okay? Thinking about the wording of your questions. Ensuring that you're using a proper sampling method. Okay? Because bias, if you're not careful, it will seep into your results. All right, kind of shifting gears into Chapter 9, randomized experiments versus observational studies. Like, this is like the biggest thing to be able to recognize the difference between a randomized experiment and an observational study. Okay, that's like, if you're gonna shut down after this class and learn one thing from this entire course, it's know the difference between an experiment and a study. An experiment, you're imposing treatment on the individuals. Okay, so you're assigning them randomly to receive the treatment or to be part of the control group and maybe receive the placebo. In an observational study, you're merely observing existing behavior. Okay, so the individuals are placing themselves naturally into the two groups, the comparison groups. Okay, they smoke or they don't smoke. Okay, they choose to exercise 30 minutes a day or they choose not to. Okay, however, that could also be assigned to them. Okay, there are some cases where you could do a study as either an experiment or an observational study. Remember that the big benefit of an experiment is that you have the possibility of concluding causation. That the explanatory variable does in fact contribute or cause a change in that response variable. You cannot determine that conclusion from an observational study because of the lurking variables. They confound our conclusions, our process. With a randomized experiment, you are randomly assigning people to the treatment group and the control group. The lurking variables that naturally exist, if your sample size is large enough and representative of a population it's describing, those should be randomly distributed and balanced out between the two groups as well. In an observational study, you don't have that random assignment. And we see many of these lurking variables, they get like clumped together. And because they're clustered together, at the end of it, and you see a difference, you cannot definitively say that that difference exists because of the explanatory variable. It could have been the explanatory and this lurking variable, or several of these lurking variables that are confounding the process. So that's not to say that results in observational studies are worthless, but you cannot get causation. You can say there appears to be a relationship between these two things. You might be able to say, like, well, there's these two variables interact with each other. If it's present, we see this change. If it's not present, we don't see this change. Okay, we saw that with the smoking during pregnancy. Exercise was an interacting variable. The mothers who smoked and exercised, there was no real difference with the IQ of their children. But the mothers who smoked and did not exercise, those children did seem to have a lower IQ. Okay? But you cannot say that it's causing that change. We talked about the treatment groups and the control groups, the use of placebos. The placebos help facilitate the blinding for the control group. Okay? So we don't want any like psychological implications of, well, they're getting this pill, I'm participating in this study, and I don't get any pill, so how do I expect to see any change? Okay, the placebo helps take care of that. Now, we did see our video on the placebo effect, but sometimes you still see change even when just taking the placebo, and there's no chemical reason as to why that change should be occurring. To try to justify the effectiveness of a drug, you need to show that it's more effective than the placebo. We've talked about some of the difficulties and disasters with sampling and experiments and studies. More recently with ethics, institutional review boards, informed consent. And remember, the review board kind of approves the ethical procedures of a study. The informed consent is what the participants will sign off on when they're participating. And then we've already spoken about confidentiality versus anonymity. Any questions up to this point? Okay, almost done here. Last thing, I have a few terms here. We've already spoken about a census. Let's jump down here. Random. Every unit in the population has an equally likely chance of being selected. Okay, sometimes people have this misconception of what random means. And they think that it's actually more of like a convenience sample where like this person, this person, this person. That's not random because not everybody has a chance of being selected. Okay, we put a lot of trust in that randomization. Ecological validity. I've mentioned this quite a bit. If you take a variable out of their natural setting and are measured in an artificial setting or a laboratory setting, they may no longer function as they would in their natural environment. Remember, we talked about that example of the mid-1980s when they introduced that third brake light on the cars, where the initial results were very promising in that it had like a 50% reduction rate in the rear end collisions when you had a few cars out there with that third brake light. But that was not common at the time. So it really stood out. It was impactful to the other drivers to see this third brake light. So they saw a big reduction in the rear end collisions. So they said, this is really promising. Let's make it law that all new cars have these third brake lights. So a few years down the road, when a lot more cars have this on them, it's not as eye-catching. And they did see a slight reduction in the number of rear-end collisions, but it was down to like 5% instead of 50%. So this is an example of ecological validity. It's not like laboratory in the sense of like some scientific lab. It's laboratory in the sense that it's an artificial setting. Okay, it's a trial. Okay, it doesn't have realism when you carry it over to its practical use. That is ecological validity. All right, last thing I want to discuss is margin of error. This is the only math that we've had in this unit. Margin of error is 1 over square root of n. Okay? N is the sample size. Let me go back to my whiteboard here. I could ask you two types of questions based off of margin of error. One is where I give you the sample size, and I ask you to compute what the margin of error would be. So let's say there was a survey where 60% of the participants favored candidate A. Okay? And there were 100 people surveyed, so that's the sample size. So 60 of those 100 chose A. Well, our margin of error calculation, 1 divided by the square root of 100. Square root of 100 is 10. 1/10 as a decimal, 0.1 or 0.10. So we interpret this as a percent. Our sample proportion was 60%, but there's a 10% margin of error. So plus or minus 10% gives you this window. Remember, I said that we don't really care about the sample. 60% of our sample said this. What we care about is the population. There's no guarantee that that sample value matches the population value. So that serves as our anchoring point where we go below and above with the margin of error. So we are pretty confident that the actual population value is between 50% and 70%. Now, that's a pretty wide margin there of 20%. Okay? It's dictated by the sample size. Sample size of 100 sounds pretty good, but it's not really big enough. If we were to use a sample that was larger than that, we could greatly reduce that window and kind of zoom in on the accuracy of our results. Now remember I said that a lot of these nationwide polls use a sample of around 2,000 people because that gives you a margin of error of around like 2.5%. It's a much smaller window and a higher degree of accuracy. I could also ask you to reverse this process, where I could give you a I give you a margin of error, and I ask you to determine what is the sample size that would give you that margin of error. So this is a little bit algebraic here, but I mean, you've all passed at least Algebra 2. Treat that 5% as a decimal. So 0.05 equals 1 over the square root of n, and we're solving this equation for n. So there are a few ways to do this, but one of them is to think of it as like a proportion. Put this 0.05 over 1 and cross multiply. You guys love to cross multiply. 0.05 times square root of n equals 1 times 1. Divide away 0.05 on both sides. And this is actually equal to 400. Or not 400, 40. No, not even 40, it's 20. Getting ahead of myself. That's equal to 20. So when you have square root of n equals 20, you're squaring both sides to get rid of that square root. So 20 squared, there's that 400 that I was foreshadowing. Okay? A sample size of 400 would give you a margin of error of 5%. Not terribly complex math, but something that you should be able to do. Or at the very least, on an open note test, you can see a worked out problem in your notes already and take a new set of values and figure it out yourself. Right? Think about the format and how you can take advantage of that. Any questions? All right, so you have some practice open response questions on the bottom of this document. Okay. Margin of error questions right here. Another margin of error question. Number 3, I give you a scenario and I ask you to describe what this would look like as a simple random sample, as a stratified random sample, as a cluster sample, and so forth. Open response questions. You will have 2 or 3 of them on your test. Identify the explanatory and response variables of this. Name 2 possible confounding variables. Why is randomization in an experiment important? Experimenter effect. Would this source of bias be most likely present in a double-blind, single-blind, or no-blind experiment? And confounding variables, are they more of a problem in randomized experiments or observational studies? Okay. So, similar to what you might see on your test. Okay? I don't need a full-blown essay or anything like that. A sentence or 2 that explains it. Again, there's some multiple choice practice problems in that chapter 11 assignment that's not graded, not due on Canvas, okay, to help kind of balance out your review and your practice for Friday's test. Any questions here? All right, let's stop this.